All right, this is grade 6, unit 1, lesson 18. And in this lesson, students are going to continue practicing with their exponents using 2 for square, meaning area, and 3, meaning cubic, meaning volume. And then we're going to be connecting all of this experimental stuff with the official formula for the surface area of a cube. And we're going to continue reviewing the volume of a cube. So let's get started. So we're going to begin right here with just a little bit of exponent review. And the idea is we want students to, without really doing any calculating, which one's bigger, 10 times 3 or 10 cubed? All right. And we want, without really calculating, we know that 10 to the third power, 10 cubed, means 10 times 10 times 10, which is definitely way larger than 10 times 3. And right here, which one's bigger, 13 squared? Well, we know that 13 squared means 13 times 13, or 12 times 12. Well, we know without doing any calculating that 13 squared is larger. And then here, I'm going to have to zoom out a little bit. So we've got 5 times 97 here. And then we've got this big long thing right here. Well, that's 1, 2, 3, 4, 5, 6. So that's 6 times 97 compared to 5 times 97. So we automatically know which one's bigger. So that's a nice little bit of review, how to use logic without calculating in order to compare those two things. Right here, it says a cube has length of 5 inches. And remember, a cube, every face, every edge is the exact same. So in this case, they are telling us every length is 5 inches. Every edge is 5 inches, etc., etc. So it says we are supposed to draw a net for this cube and label its sides. All right, so that isn't actually all that hard. It's kind of nice because a classic cube net is a cross, kind of like, it looks like the letter T. You've got 4 going down, and then you've got 1 right here, 1 right here. So often if you want to fold this up, it's kind of like this one makes the top, this one makes the bottom, and these 4 kind of wrap around the cube to make that overall shape to make the cube. So there you go. There's our net. And because we know that it says right up there, the edge length is 5 inches, that means we know that all of these lengths are 5, 5, 5, 5, 5, 5, etc. And I'm not going to write all the 5s, but we know that every single one of these faces is a 5 by 5 square. So it says, what is the shape of each face? It's a square. What is the area of each face? Well, we know that the area of each face is 5 times 5, which happens to be 25 square inches. In square, I'm having a hard time writing the I, square inches. All right, so what is the area of each face? It's 25 square inches. Then it says, what is the surface area of this cube? Well, we know if each of these faces is 25, has an area of 25, in this case 25 square units, so that's 25, 25, 25, 25, 25, and 25. So a quick way to do that is 6 times 25, which, oh golly, is 150. So we know that the surface area is 150 inches squared. And how did we get that? Well, remember, each face was 5 times 5, 5 times 5, and then we multiplied by 6 because there were 6 faces. So this was that each face, there's our 5 times 5, and then we multiply by 6 for the faces, 6 faces. Now the question is, what is the volume of this cube? All right, well, in this case, it's going to be 5 times 5 times 5. And then it's going to be inches cubed, or cubic inches. So 125 inches cubed. Now, why is that? Well, 5 times 5 tells us how many cubes are in that top layer, which is 25. But then we have 1, 2, 3, 4, 5 layers. So 25 times 5 gives us 125. So there is our answer, and plus a hint at what the formula is going to be. So let's continue. So a second cube has edge lengths of 17 units. In this case, they're just going to units. So we know that every single edge length is 17, 17, 17, 17, etc., etc. So it says draw a net for this cube. Great. So we're going to do that T thing again, but I'm going to go in a slightly different direction. Here's my 4, and there's my cube, and there's my cube. And so like there's my top, there's my bottom, and these are wrapping around the cube. All right, and then it says to label. So we know that all of these edge lengths are 17, etc. So it says explain why the area of each face is 17 squared square units. Well, that's pretty straightforward because it's saying the way to get the area of each face, this face right here, is length times width. Well, what's the length? The length is 17. What's the width? 17. And so the area of this face is 17 times 17, which is 17 squared. And then, of course, we should say square units, right? So this is 17 squared. This is 17 squared, 17 squared, 17 squared, and 17 squared. That's a large answer. Write an expression for the surface area in square units. Well, 17 times 17 gives us the area of one face, but then we have to multiply by 6 because there are 6 faces. And then, of course, our answer is going to be units squared. There is our work. And then question D, write an expression for the volume in cubic units. Well, remember, volume, we're going to think about how many cubes are in that top layer, and that answer is 17 times 17. But then how many layers do we have? 17. So our expression is going to be 17 times 17, that's the top layer, times the fact that we have 17 layers. And so we have 17 times 17 times 17 units cubed. Shorter way of writing that is 17 cubed units cubed. All right, let's keep going. So now they want us to generalize it. It says a cube has length S. All right, so what is that net going to look like? Well, here's our 4 going around the cube. There's my top. There's my bottom, but this time each edge length, those look like 5s, but they're actually S's. I don't know why I have no idea why they choose the letter S. Could they choose a more complicated, confusing letter? It looks like a 5. Anyway, so there's my net. So question 2, write an expression for the area of each face. So what is the area of this face right here? Well, it's going to be S times S, length times width. But a quicker way of writing that is S squared. So that means all of these faces are S squared. So write an expression for the area of each face. It's going to be S squared units squared. And then question 3, write an expression for the surface area. Well, it's going to be S squared, that's one face, times 6 units squared. So that's one face times the fact that we have 6 faces gives us the answer. And then write an expression for the volume. Well, that's going to be S cubed units cubed. Why is that? Well, we know the S times S gives us how many cubes are in the top row, times the fact that there's s rows. So there's our answer. Our expression is s cubed units cubed. So that's kind of fun. Straightforward, not terribly difficult, kind of summarizing everything we've learned. Here's the summary. There's no new vocabulary words because really we were just practicing all the stuff that we already knew. So let's do our homework. So what is the volume of a cube with edge length 8 inches? So we know that our cube looks like this. We know that each edge length is 8, 8, and 8. And so what is the volume? It's going to be 8 cubed. In this case, it's going to be inches. Cubic inches. And I don't know what 8 times 8 times 8 is. That's what this is, 8 to the third power. But you could figure that part out. It's 8 cubed inches cubed. Now, what is the volume of a cube with each edge length being a third of a centimeter? So we know it's going to be 1/3 cubed centimeters cubed. Now this one's actually pretty easy because 1/3 times 1/3 times 1/3, because that's what this 1/3 cubed means. And so that's 1/27 centimeters cubed. And actually this should have been centimeters cubed. And then number C, or letter C, a cube has a volume of 8 cubic feet. So what is the edge length? So what they're saying is we have a cube. There's my cube. Obviously, each length is the same. But when we multiply them, we get 8. So the only number where you multiply it by itself 3 times to get 8, the only way that's possible, the only way that's possible is if x is equal to 2. So each edge length is 2 feet. All right. Number 2, what 3-dimensional figure can be assembled from this net? Well, this is a cube. We know that. We've been doing that. It's a cube. Now, if each square has a side length of 61, write an expression for the surface area and another expression for the volume. So if we're talking about surface area, and they're saying that each edge length is 61, 61, 61, etc. All right. So what's the volume for the what's the expression for the surface area? Well, we know that, I'm going to do it in red. We know that this area right here for this face is going to be 61 times 61. So that's my 61 squared. And then we're going to have 6 of those because we're going to have a 61 squared here, 61 squared here, 61 squared, 61 squared, 61 squared. So I'm going to delete all these edges right here. All right. And then we're going to have 6 of them. So we're going to have our formula for the surface area is 61 squared times 6. And then our units are centimeters squared. So that's the surface area. All right, now we want to do volume. And we know that each edge length of this cube is a 61. So since each edge length is a 61, right here, right here, right here, that means our volume is going to be 61 to the third power, and our units are going to be centimeters cubed. All right, because that first couple of 61s, 61 times 61 tells you the top row, top layer, and then we have 61 layers, so 61 times 61 gives you the top row, times 61 tells us how many layers there are all together. So that's our 61 cubed. All right, number 3, draw a net for a cube with edge length x. All right, 1, 2, 3, 4, 5, 6. There is my net. And each edge length is X centimeters. There is my net. Now, what is the surface area of this cube? What is the surface area? Well, we know each face is going to be X squared because length is X, width is X. So length times width is X squared. But then we're going to have to multiply by 6. Why? Because we have 6 faces. And since we have 6 faces, 1, 2, 3, 4, 5, 6. Since we have 6 faces, we're going to multiply by 6. And so our final, with units and everything, is X squared times 6 centimeters squared. And the last question here on question 3 is, what is the volume of this cube? So we know the volume is going to be X times X times X centimeters cubed, which an easier way to write that is X cubed centimeters cubed. And then lastly, getting there. Here is a rectangular prism that was not drawn accurately. So they're telling us that this guy right here has not been drawn accurately. So our job is to explain, well, what's wrong with this picture? It's not drawn accurately. So if you think about it, this square right here is our clue, right here. So that when this edge, I'm going to do it in a different color. When this edge wraps around, it's going to extend much further than it's supposed to. It's going to extend much further. So that's our inaccuracy, is the fact that this edge is going to extend further than it's supposed to, and this edge extends further than it's supposed to. And so that's what's wrong with it. Now our job is to draw a net that can be assembled into a rectangular prism. Sure, let's do that. So a figure that can be a net that could be assembled into a rectangular. Well, we could do this one. Let's see. If we want to do, let's see. Goodness, what will we do? Let's do. If we want a square, and then kind of a rectangle, then we want a square, and then we want a rectangle. So I'm kind of basically copying what's right up here. Okay. So the issue was, what are the top right here and what is the bottom right here going to look like? All right, so let's do that. So let's use a little bit of logic. So I'm going to move this down a little bit. All right, so we know that when this guy folds up, it's got to line up. So as long as this is, that's how far it's got to go up. Same thing on this side. So now this is going to match there. And then this is going to match there. And then same story. Let's see. Let's do it down here. Same story down here. So this edge is going to line up perfectly right there. And then this edge is going to line up perfectly down there. And we now have our net. All right. And then create another net for the same prism. Oh my goodness. Well, it looks like we could probably copy this and paste it right here. But then to change it, all we have to do is take this guy and move it right here. Take this guy and move it right here, and it still works. Look at that. That's kind of cheating, huh? I love it. Okay. Number 5, state whether each figure is a polyhedron. Is this a polyhedron? Nope. 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 Because it has curved edges. Automatically, it's not a polyhedron. How about this guy? Yep. He's okay. Because he's got nothing but straight edges. It's got 2 parallel bases. It's all good. It's a good one. That's a nice little review question. So number 6, here is Elena's work for finding the surface area of a rectangular prism that is 1 foot by 1 foot by 2 feet. So 1 foot by 1 foot by 2 feet. My goodness, there's just numbers all over the place. Goodness gracious. She concluded that the surface area of this prism is 296 square feet. Do you agree? No, there's just no way that the surface area can be basically 296 squares, right? She is saying that to cover this figure requires 296 little squares that are each a foot, 1 foot by 1 foot. Golly, there's no way, because they're describing this as a 1 by 1, it's right up here, 1 foot by 1 foot by 2 feet. There's no way it's going to require 296 squares, 1 foot squares, square foot, to cover this thing. So it just doesn't make sense logically, right? And really, if you want to think about it, a 1 by 1 by 2 is going to look more like this. And here is my 2. So what is the surface area of this thing? So remember surface area. Well, the front has an area of 2 for the blue. And then the green has a surface area of 2. And then the orange has an area of 1. So we've got 2 blue, 2 green, plus 1 orange. That equals 5. But then remember, you got to do 5 times 2 because each face has a partner. So the green has a partner on the other side. The blue has a partner. Everybody has a partner. So 5 times 2 is 10 square feet. So really, the surface area of that prism is 10 square feet. Nothing even remotely close to 296. Goodness gracious. And that wraps up 6th grade, Unit 1, Lesson 18. We're continuing to practice volume, surface area, and then exponents, using that little 2 to represent square, meaning area, and cubed, meaning a little 3, representing cubic, which is associated with volume.